In this series, I'm going to build a processor that executes raw Brainf code. I've already worked out most of the design ahead of time, so I won't be working through that side of things too much, but I will record the build process. The first step is to build a clock. I've chosen to start with a single-step clock, following Ben Eater's design. His schematics are linked in the video description. That should be everything completed. Time to test it. All this specific clock really does is remove the electrical noise from the push button to make it usable as a clock signal. You can't see it with your bare eyes, but every time the button's contacts open or close, they bounce and arc, producing momentary connections. These appear to the processor as multiple clock pulses and cause very unexpected behavior. I'm going to add a power light here so I can see when the system is on. It's not really necessary, but it might be helpful in the future. Unfortunately, because of how densely packed this board is going to be, I had to put the power light where I was powering the board. I'll just change this bit up to make room for the power cord, and that should be problem solved. I've used a piece of bare wire as a single space jumper here. As you can see, the bottom of this button is all plastic, so I'm not worried about shorts. The only issue is that the button sits slightly crooked, but I'll deal with that later when I have more spots for the power cord. As you can see, the power light works as intended. As a bonus, the clock also still works. Now I'm going to build the low-speed clock. Unlike the single-step clock, this one runs continuously. I don't know about you, but unless I'm debugging, I'd rather not be single-stepping every program I run. There we go. I do believe that's the whole thing. Let's plug in power and test it. Perfect. It works. Now I have two clocks. The low-speed clock that I'll use most of the time, and the single step clock that I'll use for debugging. The low speed clock can be adjusted with this potentiometer. Turning it clockwise makes the clock faster. Turning it counterclockwise makes it slower. I think I'll go ahead and leave it right about here. In order to keep the clocks evenly spaced here, I need to make this potentiometer section more compact. I'll do this by rotating it around and putting in a shorter wire. Looks like it still works. That's good. Now I'm going to put together the high-speed clock. The design of it is identical, except it is set much faster. And it works! It's about as fast as the low-speed clock though, so let's adjust it. For now I want to set the high-speed clock slow enough that you can still see it blinking, but still much faster than the low-speed clock. I think I like it about there. I notice while adjusting the high-speed clock that the potentiometers are now backwards. I have to rotate counterclockwise to increase the speed. It's not mission critical, but I don't really care for it, so I'm going to go ahead and fix it. That's all I have for this episode. I hope to see you next time. If you have any feedback, please do let me know by leaving a comment below. All resources mentioned in the video are linked in the description. Thank you and have a great day.